morning students, welcome back. We'll continue exercise 1.4 8th sum. Find the square root of the following decimal numbers and fractions. We completed up to decimal numbers. Now we'll move on to the fractions. Square root of 144 divided by 225. This we can write it as square root of 144 divided by square root of 220, which is equal to, this is nothing but square root of 144 is nothing but 12 into 12 by square root of 15 into 15, which is equal to, for square root of 12 into 12 you will take 12 outside, and square root of 15 into 15 you will take 15 outside. Therefore the answer is 12 by 15. Now we'll move on to the fifth sum. 18 by 49, which is equal to, this one is a mixed fraction, convert into improper fraction. So here 7 into 49, 343 plus 18, it's nothing but 361 divided by 49. So this is a mixed one, we are converted into improper. For that you have to take the square root. So square root of 361 by 49, which is equal to square root of 361 by square root of 49. So 361 is nothing but square root of 19 into 19. Here 49 is 7 into 7. Therefore the answer is 19 by 7. Clear, children? Now we'll move on to the next question. So ninth question, find the least number that should be subtracted to 6666 so that it become a perfect square, and also find the square root of the perfect square thus obtained. For that you take 6666 and find the long division method. Find the square root for the long division method. So pair the numbers. For this 66 you will take 8 8s are 64, remainder 2, bring down the two numbers 66. Here 8 2s are 16. If you multiply with 1 you will get 1 1s are 1, 1 6 is 6 and 1 1 is 1, and if you subtract it you will get 105. Therefore, so you have to write like this, 105 should be subtracted to 66666 to make it a perfect square. If you subtract 6666 minus 105, you will get 6561. Therefore, square root of 6561 is equal to, it's nothing but square root of 81 into 81. Therefore, which is equal to 81 is the answer. So copy down, children. Now we'll move on to the 10th question. Find the least number by which 1800 should be multiplied so that it becomes a perfect square. Also find the square root of the perfect square thus obtained. Here they are asking for the subtraction, so we find it for the long division method for 6666. Here they are asking for the multiplication, multiplied. So we have to do it in the prime factorization method itself. So prime factorization for 1800, you do it in 5 tables. 3 5s are 15, remainder 3, 6 0. Again you go it for 5 tables. 7 5s are 35, remainder 1, 2 times. Again you go for 2 tables. 3 2s are 6 and 6 2s are 12. 2 tables. 1 2 is 2, remainder 1 8 times, again 2 table, 9, 3 3s are 9. So therefore the factors for 1800 are 5 into 5 into 2 into 2 into 2 into 3 into 3. So here this is pair and this 2 are one pair and this 3 is in pair, but only thing is this 2 is in the 2 is standing alone. So if you multiply one more 2 to this number, therefore 2 should be multiplied to 1800. If you multiply one more 2 to this number, to this factor, you will get 2 another 2, so you will have a pair. So we will make it into a, to make it a perfect square, so it will become a perfect square. We will find what is the multiplication 1800 into 2. So we got 3600 if you multiply with 2. So we will find the square root. They are asking for the square root of 3600. So you got 60 into 60. 60 into 60, square root of 60 into 60, you take 160 outside. Therefore square root of 3600 is 60. So like this only you have to find the multiple, which what should be multiplied, 2 should be multiplied, and square root of 3600 is 60. Copy down, children. Now we will move on to the exercise 1.5. First two sums are fill in the blanks and true or false. We will move on to the third sum. Show that 1944 is not a perfect cube. For finding the cube root, the only method is prime factorization method. We will follow the prime factorization method. Two tables, and 9 2s are 18, remainder 1 14, 7 2s are 14, 2 2s are 4. Again you go for two tables. 4 2s are 8, remainder 1. 8 2s are 16, remainder 1. 6 2s are 12. Again you go for two tables. 2 2s are 4, 4 2s are 8, 3 2s are 6. This you can go it for the three tables. 24 is 8 times, and 3 1 3s are 3. Again we can go it for three tables. 2 3s are 6, remainder 2. 21 7 times. Again you go for three tables. 9 times. Again you go for three tables 3 times. So like this only you have to do the prime factorization. So factors for 944 is 2 into 2 into 2 into 3 into 3 into 3 into 3 into 3. So they asked us whether it is a perfect cube or not. Perfect cube means it should have 3 pairs. So 2 we are having three numbers, 3 we are having 3 numbers, but here only 2 numbers are there. If you have one more 3 only, it will become a perfect cube. So therefore 1944 is equal to 2 into 2 into 2, 3 into 3 into 3, and we are having 3 into 3. If you have one more 3, then only it is a perfect cube. Since it's having only 2 3s, 1944 is not a perfect cube. Okay, now we'll move on to the next sum. Find the smallest number by which 10,985 should be divided so that the quotient is a perfect cube. They are asking that we have to make it into a perfect cube. So take this and find the prime factorization method. We will find it from the 5 tables. 2 5s are 10, 1 5 is 5, remainder 4, 48, 9 5s are 45, remainder 3, 35 7 times. So here 2197, it's go by 13th table, 169. So 169 is also 13 into 13. Therefore 5 should be divided to 10,985 to make it into perfect cube. If you divide this 5, you will get 13 into 13 into 13, so it will become a perfect cube. So we will, and also they asked us to find the, now we will move on to the fifth sum. Find the smallest number by which 200 should be multiplied to make it into perfect cube. Here we will go for the 200, go for the prime factorization method. So go for 5, 4 5s are 20, put 0 and one more 5, 8 5s are 40, 2, 4 times 4 2s are 8, again 2, 2. If you take for this 200, we are having 5 into 5 into 2 into 2 into 2. What is the question they asked? What should be multiplied? If you multiply one more 5 here, you will get 3 5s, and already 3 2s are there. So to make it into a perfect cube, we have to multiply with one more 5. If you multiply with one more 5, we will get 3 5s, then it will become a perfect cube. So what you will write, therefore 5 should be multiply to 200 to make it into perfect cube. Clear, children? Now we move on to the next question. Here, find the cube root of 24, 36, 80, 25. Find the factorization, prime factorization for each and every number, and we will find the cube root. We will see how to do the sum. So cube root will represent, put the square root symbol, and inside this v you have to put 3, that means cube root. So we are going to find the cube root of, look at this children, you have to put cube root for this only, you have to put 3 here and you have to put the square root symbol, then only it will represent the cube root. For 24, 36, 80 and 25. Find separately square root, prime factorization for 24 and prime factorization for 36 and prime factorization for 80 and prime factorization for 25. So you have to find a prime factorization for each and every number. So I have found it for 24 is 2 into 2 into 2, 36 is 2 into 2 into 3 into 3, 2 into 2 into 2 into 3, this is 24. For 80, 5 into 2 into 2 into 2 into 2, for 25, 5 into 5. So which implies cube root of 24 into 36 into 80 into 25 equal to cube root of, for 24 you write 2 into the factors, 2 into 2 into 2 into 3, 2 into 2 into 2 into 3, and for 36 2 into 2 into 3 into 3, 2 into 2 into 3 into 3, and for 80 5 into 2 into 2 into 2 into 2, 5 into 2 into 2 into 2 into 2, and for 25 you will get 5 into 5. So like this you have to write all the factors. After that, for 3 numbers you write for the 3 numbers 2 into 2 into 2, and again 2 into 2 into 2, 2 into 2 into 2, again you go for 2 into 2 into 2, 2 into 2 into 2, then you go for the 3 into 3 into 3. You have to pair the numbers, separate the same numbers in one time, 2 allow one side, 3 allow another one, and 5 into 5 into 5, 5 into 5 into 5. Now look at this, for 3 3s, since it is a cube root, for 3 numbers you will take 2 outside. Here 3 2s are there, you will take 1 2 outside, and one more set is there, 2 into 2 into 2, so you take 2 outside, and one more set, so into 2. Are you able to understand, children? For this set you will take 1 2 outside, for this set you will take another 2, and for this set you will take another 2. Now look at this 3, this is one more, so you have to take 3 outside, and 5, 1 2 3 5s are there, so take 1 5 outside. So now you have to multiply this, 2 into 2, 2 2s are 4, 4 2s are 8, 8 into 3 5s are 15, multiply 40, 8, 9, 10, 11, 12. So the answer is 120. The cube root of 24 into 36 into 80 into 225 is nothing but 120 is the answer. Now we'll move on to the next question. The next question, 7th question is, find the cube root of 729 and 6859 by prime factorization method. So 2 sums are there, we have to do one by one. First we will take 729. prime factorization method. This is a prime factorization method. If you do the prime factorization method, you will get 3 into 3 into 3 into 3 into 3 into 3. So as I said earlier, for the cube root you have to put the symbol like this. You have to put the square root, and inside that v you will put 3. That means cube root. Cube root of 729 is nothing but 3 into 3 into 3, 3 into 3 into 3, and 3 into 3 into 3, 3 into 3 into 3. Since it is a cube root, for 3 numbers you will take 1 3 outside, and here also one more 3 sets are there, you will take 3 outside. Therefore, the cube root of 729 is 3 into 3. 3 3s are 9 is the answer. So, therefore, cube root of 729 is 9. So, the second subdivision is 6859. 6859, 19 times. So, since it is a prime number, so you have to take the 19 only. 19 times you will get 361. Again you will go for the 19. So, cube root of 6859 is equal to cube root of 19 into 19 into 19. Here 3 numbers are there. For 3 numbers, 19 into 19 into 19, you take 19 outside. Therefore, cube root of 6859 is equal to 19. Second subdivision is over. Now we will go for the next sum. Now we will move on for the 8th question. What is the square root of cube root of 46,656? So this is the given question. Square root of cube root of 46,656. First we will find cube root of 46,656. We will go for the prime factorization method. 2 tables, 2 2s are 4, 3 2s are 6, 3 2s are 6, and 2 2s are 4, remainder 1, 8 2s are 16. Again go for the 2 tables. 1 2 is 2, 1 2 is 2, remainder 1, 6 2s are 12, remainder 1, 6 2s are 12, and here 4 2s are 8. Now again you go for the 2 tables. You take this 2 digit, 5 2s are 10, remainder 1, 8 2s are 16, and 3 2s are 6, 2 2s are 4. Again go for the 2 tables. 2 2s are 4, remainder 1, 9 2s are 18, and 1 2 is 2, remainder 1, 6. Again you go for the 2 tables. 1 2 is 2, 4 2s are 8, 4 2s are 8, remainder 1, 5 2s are 10, remainder 1, 16, 8 2s are 16. Again you go for the 2 tables. 7 2s are 14, and 2 2s are 4, remainder 1, 9. This 729 will go by 3 tables. That 243. Again it will go on the 3 tables. 24 will go for the 8 times. 8 3s are 24, 1 3. Again it will go for the 3 tables. 27. Again it will go for the 3 tables 9 times. Again it will go for the 3 tables 3 times. So since it is a bigger number, we will got this much bigger prime factorization. Now we will find it for the cube root of 46,656 equal to cube root of, so write all the numbers, 2 into 2 into 2, 2 into 2 into 2, and 3 into 3 into 3, 3 into 3 into 3. As I said earlier, for this pair 1 2 3 numbers you will take 2 outside, and for these 3 2s you will take 2 outside. This pair you will take 3 outside, and this set you will take 3 outside. This is the value of cube root of 46,656. Now they asked us to find, now we will find square root of cube root of 46,656. Already we found the cube root of 46,656. Now they asked us to find the square root. Square root we can write like this: square root of 2 into 3 into 3. So the value of cube root of 46,656 is 2 into 2 into 3 into 3. Now again we have to find the square root. For square root, for two numbers you have to take outside. For pair of numbers, for this pair you will take 1 2 outside, for this pair you will take 1 3 outside. So therefore the value of square root of, write the question, square root of cube root of 46,656 equal to 2 into 3. 2 3s are 6 is the answer. Like this only you have to complete the answer. The next question, ninth question, if the cube of a squared number is 729, find the square root of the number. That means let the number be x. What they are asking, they asked us to find the squared number of cube is equal to 729. If you are not able to understand, just take cube root of this. Cube root of 729, then you take square root of this. This is equal to this. Clear? Now we have to find what is the prime factorization of 729. So we already found it. It is nothing but 3 tables only. 243, again 3 tables will get 81, again 3 tables will get 27, again 3 table 9, again 3 tables 3. So it is nothing but, which is equal to square root of cube root of 729 is 3 into 3 into 3, 3 into 3 into 3. So for cube root you have to take 3 numbers, 3 sets, 1 3 outside. So square root of 3 into 3. So if you take square root of 3 into 3, it's nothing but 3. Clear? This is the answer. So therefore x is equal to this. And they asked us to find square root of x. So therefore square root of x is equal to square root of 3. So square root of 3, you have to do it in the long division method. 3 you put, and 1 here also 1 ones are 1, remainder 2, put the dot, you add 2 zeros. So if you multiply 1 with 2, you will get 2. 7 times you take 7, 7 sevens are 49, and 7 2s are 14, 15 16 17 18, you will get 189. If you subtract it, you will get, so you will get the remainder is 11. Already we multiply 1 with 2, so you put the 2 itself, and 7 with 2 you will get 14. 4 you put here, and 1, that 1 you have to add it with this number, so you will get 3. Now add 2 more zeros, then 3 times 3 3s are 9, 3 4s are 12, remember 1, and 3 3s are 9, 9 plus 1 10. Again you can subtract it, so it will goes on. Therefore you will stop up to 1.73 approximately. It is equal to 1.73. This is the answer for the 9th sum. Copy down, children. The 10th question is, find the two smallest perfect square numbers which when multiplied together gives a perfect cube number. 10th question, solution. Smallest perfect square numbers are, will take 4 and 16, and they asked us to multiply this 4 and 16. If you multiply, you will get 64, and it should be a perfect cube. We will check whether it is a perfect cube or not. 64, 2 tables, 3 2s are 6, 2 2s are 4, again 2 tables, 1 2 is 2, remember 1, 6, again 2 tables, 8 times, 2 tables, 4 times, 2 times, 2 times. So therefore cube root of 64 is equal to cube root of 2 into 2 into 2 into 2 into 2 into 2, which is equal to 2 2s are one set you will take 2 outside, and one more set you will take 2 outside, 2 2s are 4. So therefore 64 is perfect cube. So what they are asking, we have to take a smallest perfect square numbers. This is a square number, am I right? Perfect square. 4 is a perfect square and 16 is also a perfect square. If you multiply two perfect square, we are getting a perfect cube. That is 64 is a perfect cube. Therefore the smallest perfect square numbers are 4 and 16. So up to this exercise is completed, and that is why 1.5 is completed. Okay children, now we will move on to the next exercise 1.6. I am not going to start that next exercise. Before that, you have to know something about the exercises. The next exercise is consist of exponents and powers. So only the introduction part we are going to see today. Next video we will see the exercise sums. So what is meant by exponents and power? We will take 5 power 2. So this can be, this 2 we can say it as exponent. This 2 we can call it as exponent, and this we can call it as base. So altogether we will say 5 to the power 2, we say this as 5 raised to the power 2. So before going to start this exercise, you have to know what is meant by 5 to the power 2 raised to the power 2, 5 raised to the power 2. This 2 is called the exponent, this 5 is called a base, which means 5 to the base 2 means 5 to the power 2 means 5 into 5. So we can write 5 into 5 as 5 to the power 2. Are you able to understand? Yeah. I will give one more example. 3 to the base 4. 3 to the power 4. 3 to the power 4 means 3 into 3 into 3 into 3. That means 3 we have to write it as 4 times. Clear? Here 4 is called the exponent and 3 is called the base. Now we will proceed the sum. We are not going to proceed the sum. Before that we will know some formulas. Power with 0 and negative exponent. The first formula is a power 0 is equal to 1. Anything power 0 is 1. The second one is negative. A power minus m is equal to 1 by a power m. And now we will go for the laws of exponents. After that we will continue. This is second one. We will go for the third. A power m into a power n equal to a power m plus n. The two powers you have to add it. So note down, a power 0 is 1. A power minus m is equal to 1 by a power n, a power m, and the third one is a power m into a power n equal to a power m plus n. Fourth one, a power m by a power n is equal to a power m minus n. The last one, This is quotient formula. This one is product, this one is quotient, the last one is power rule, power law. A power m the whole power n is equal to a power m into n. So all the 5 formulas you have to memorize it. Then only we can proceed in the exercises. So in this class you memorize all the 5 formulas. Next class I will ask the formulas. Clear children? So you sit and revise the 3 laws and the 2 powers with 0 and negative exponents. So altogether 5 you have to memorize it. Thank you children. We will see in the next class.